Okay, in this lesson we are to find the derivatives of inverse trigonometric function. First of all, we identify the inverse trigonometric function. Okay, these are the inverse. So sine inverse of x, cos inverse of x, tan inverse of x. So if you have to find the derivative of the first, okay, so let's find the sine inverse, the derivative of sine inverse of x, that is the y dx. First, we cannot differentiate this directly because it's not possible. So you rearrange it. This implies that sine y is equal to x. Okay. For example, sine 30 is 0.5. So if y is 30, x is 0.5. Sine 30 is 0.5. So sine inverse of 0.5 will give us back 30. So that sine inverse of 0.5 will give us back 30. So that is how I explain that. Now, we say that we can differentiate this because if we differentiate sine y, you can easily get cos y. So let's go. So we differentiate sine y. We have the y, the x, cos y. Each time we differentiate dependent variable, you must add the y, the x. Okay? But x is independent variable, so if you differentiate x, you get 1. Okay? So divide this side by cos y. Divide this side by cos y. You see that the y, the x is equal to 1 over cos y. So recall that sine squared y plus cos squared y is equal to 1. So we make cos y the subject of the formula, and we have this. So it's very important to take note of this expression as we make it fit. This is cos y. We substitute it, and we have that the y dx is equal to 1 over equal to 1 minus sine squared y. Okay? As sine y is x, we have therefore that y dx is equal to 1 over square root of 1 minus x squared. Very correct. So in the second question, it's the same thing. Y equal to cos inverse of x. Find the y dx. We have minus 1 over square root of 1 minus x squared. Okay? So the only difference between sine inverse of x and cos inverse of x is negative sign. They are the same process. So number 3 is different process entirely. Y equals tan inverse of x. Okay? So the same we say tan y is equal to x, which implies that if you differentiate tan y, you have the y dx to give the y dx to give us bracket open sec squared x, but there is y, we have sec squared y. Okay? There's a bracket always attached the y dx to the term y whenever you differentiate it. So if you differentiate from y, you get x squared y. You add the y dx, which is equal to differentiate x over y. Okay, which implies that the y dx is equal to 1 all over sec squared y. Now we know that sec squared y is equal to 1 plus tan squared y. Okay, from triple identity, very important. So that the y dx is equal to 1 over 1 plus tan squared y, but tan y is equal to x as it is written here. So the y dx is equal to 1 all over 1 plus x squared. So when you're asked to differentiate tan inverse of, so in summary, if you're asked to differentiate tan inverse of x, the y dx will give us 1 over 1 plus x squared. So the difference between tan inverse of x and cot inverse of x is negative sign. Cot inverse of x is minus sign, is the same thing as we did in cosine inverse of x and cos inverse of x. So we have the same answer, but the sign is negative. So you're asked to differentiate cot inverse of x. The answer to tan inverse of x is 1 over 1 plus x. We just add minus sign to it. That is cot inverse of x. Alright? Bye.